Hey guys, here's another interesting question on quantitative comparison. It's asking us to compare the number of positive integers of a constant x with the number of positive integers of another constant y. You see the figures and you're like, oh, 350,000, 45,000. How am I going to know how many divisors are in there? Relax, guys. There's a way around it. If you didn't know any trick, your best bet would be to make a guess and then move on. But if you want to list all the positive integers that can go into x, that will take you like the whole time you need for the whole exam. So let's see how we solve this one. Now, for any positive integer, if we are able to express it as a prime factorization, then we can find a number of positive integers that can go into that integer. So I'll do an example and then we'll apply it to the question. When we talk about number of positive integers that are divisors of another integer, then we are looking for actually the factors of that integer. So case in point, the integer 2 has 2 factors, 1 and 2. Integer 4 has 3 factors, 1, 2, and 4. Integer 6, we have 1, 2, 3, and 6. That's 4 factors. So how do we know this integer has this number of factors? So that's what we're going to do. So if we have an integer, let's say 20, what we do is to express it as prime factors. So if you remember back in basic school, you write 2 and 10 and then break 10 down to 2 and 5. So how many 2's are there? 2 2's. How many 5's are there? 1 5. So here it tells us that we have a prime factorization with unique primes of 2 and 5. So if you want to know how many factors there are in there, then you pick this 2, add 1, so we have 3. Pick this one, add 1, so we have 2, and then we multiply. So we can say 20 has 6 factors. Of course, factors are positive integers that are divisors of another integer. So we'll apply this same reasoning here and we will solve the problem. So if I move way down and I write, let me take a look again, 350,000. 350,000. Now if you're going to use your basic school approach, don't start with 2. This is going to be 175,000. This is going to be a whole messy. It's going to be so messy. You'll have to be a bit creative about it. So instead, let's clean all this and then write 350,000 as 35 times 10 power 4. Okay, and then we can write 35 as 5 times 7 times 2 times 5 power 4. What we want to do is to get a prime factorization of the number. So you realize that I've broken down 10 into 2 and 5. So that at the end of the day, if we group them, we have 5 5's, 1 7, and 4 2's. So how many factors has 350,000? Once we break it down to its prime factorization, then we can get the number of factors 350,000 has. So we pick the 5, we add 1. We pick the 7, obviously, to power 1. We add 1, so we have 2. We pick the 4. We add 1, so we have 5. So how do you multiply this very quickly? So we have 6 to 5. How do you multiply very quickly? On the exam day, it's easy to multiply by 10 and 5 and co. So we can say 6 times 10, and that's 60. Now we are going to do same for 45,000. So we have 45,000. This is 9 by 5 by 10 power 3. So clearly this is 3 squared by 5 times 2 power 3 by 5 power 3. The same thing we did here. So I just did it straight away. So we group them, and then we have 3 squared times 5 power 4 times 2 power 3. Now we add 1 to the powers, so 3 times 5 times 4. So how do you multiply this very quickly? We can do 3 by 20, and that's also 60. So clearly we see that 45,000 has the same number of factors as 350,000. So if you were to guess, if you don't take care, your best bet would be to go for X as the greater one, but from what we did, you realize they are equal, so our answer is C. Now if you don't take care, this can waste your whole time. Now if you do it pretty quickly, like I've done, this can take 1 minute for you to solve this question. Okay guys, hope you enjoyed it. See you later. Bye.